Hi, I'm Sydney Spector, and my project investigates phthalates, chemicals often found in so-called green products that we may come into contact with every day, such as home cleaners. The danger is for people who are attempting to find a healthier, eco-friendly alternative to harsh cleaners, such as bleach or ammonia. They buy a product marketing itself as green or natural, unaware that those terms have no regulation and quite often mean nothing. The buyer then feels more comfortable using what they perceive as a safer chemical and take less precautions, most likely coming more into contact with the product than they would have otherwise. They do not realize that to avoid the use of bleach or ammonia, the green companies will use chemicals that are just as harsh, if not in name, to get the same desired effects. This is where phthalates come in. Phthalates are plasticizers, used to keep the almost elasticy, soapy consistency of cleaners despite their abnormal recipe. I focus specifically on diisononyl phthalate, as it is one of the most commonly used due to its low price and high durability. Diisononyl phthalate is particularly important because of its absorption rates into the human body. If swallowed, the absorption rate is 50% through the gut, compared to the near 75% absorption rate through the respiratory system. If someone is using a spray cleaner in their home, they are much more likely to be breathing in the sprayed vapor than swallowing it, especially as most people do not wear protective masks while cleaning their own homes. Diisononyl phthalate, like its relatives, has been found to cause numerous health issues in the body, like reproductive complications, toxin poisoning, and many types of cancer. There have also been links between the use of this chemical and issues in the respiratory system, but somehow this is not as studied as the other health concerns, despite how the most direct and potent introduction of diisononyl phthalate into the body is by inhaling it. This is why I chose to focus on the effects on the respiratory system, using a yeast model. My main obstacle was that yeast do not traditionally breathe. To circumvent this and still maintain a somewhat accurate introduction method, I used a baby nebulizer. I refit the tubing to accommodate our lab flasks and then filled the cartridge that usually contained medicine with various concentrations of phthalates based on worldwide regulations on all phthalates, specifically from the EU. I then let the nebulizer run, turning the phthalate solutions into water vapor without heating them, which could affect the chemical, and then sent the vapor into the yeast flasks. I then ran an RNA isolation protocol on the yeast to be able to analyze the human homolog respiratory system genes. I chose genes that are normally affected by major respiratory illnesses, many thought to be caused possibly by phthalates. I'm now working on getting more concrete results.